Okay, since the broadcast is on, hello everybody. My name is Michael Floyd. Welcome to Weekly Webinar 6. I am your mentor and your mentee. You learn as much from me as I learn from you. So now just going over some things we went over last week. You meet with me to fill out the introduction forms. Those are still not completed, if at all possible. 5 out of 14 of you were missing last week. 5 out of 14 still again this week. I was hoping it would change, but it is not. I emailed you guys. I'm hoping you set up Calendly meetings with me. My schedule is available Tuesdays, Wednesdays. If you cannot make it those days, message me on Slack and set a meeting up for a different day besides Tuesday or Wednesday, and I will try to make that happen. Now, we are still in a state of emergency. The reason why I say that is 10 out of 14 of you still have not turned in Project 1. Project 1 is past due now for a couple of weeks. The disappointing thing is I don't see any questions on your Slack channels. So it would feel to me like everything is going fine, but it is not. Right? We need to make sure we can progress and move along and become the data scientists and get the jobs that we desire. Okay. So, like I say, every webinar as well, the money is already spent. And I know a lot of you have busy schedules, but I give you examples every time of 3 students. Right, student A doesn't have a busy schedule with his parents, 0 adult responsibilities, but student A will most likely still find a way to make an excuse for himself. Right, students B and C may have the wife and kids, but the difference between student B and C is that student B accomplishes all of his duties while doing this. Meanwhile, student C gets things done, right? His boss asks him to work late. He does not mind because he works on his narrow degree during work anyway, right? His wife gets sick. He gets another wife. His toilet gets stopped up. He uses the sink, right? Student C gets things done, right? And in the sake of this narrow degree, student C gets things done. So I hope we all can be like student C, maybe a little bit in between student B and student C as far as everybody's the public's health, right? Student C, his car battery goes out. Student C hijacks a car, right? Student C is definitely pursuing this narrow degree to its fullest capabilities. I'm hoping we all can reach the level of student C. But now let me get through the other things we did not cover last week in the week 5 webinar. The most important things, which is to see how much your instance is and to terminate your instance. I hope all you guys did not run instances with me while doing this. And if you did, terminate the instance now. Amazon is running money through your account. Okay. So yeah, terminate the instance, especially if you got a P2 GPU like similar that I did. It costs what, I believe 9 cents or 90 cents an hour or something like that. It's not too expensive unless you've been running it for a week, right? And walk through project 1. That is the last thing, well, that is the next thing I'm going to do. That's what we're going to cover today is walk through project 1 because 10 of you have not got through project 1. So I'm hoping that this walkthrough will help you get through project 1 and hopefully all 10 submit the project by the end of this week. And once that is submitted, then we can all begin on project 2 and begin on the lessons from project 2. All right, let me share my screen. All right, my screen is shared. And let's go to the project walkthrough. Now, I gave a project walkthrough already, but it wasn't as in detail as I'm going to do right now for you. A lot of the things I'm looking at realize that I can't give you the answers to. These things are more crucial to your understanding of the Python modules and this coursework as well. So, but I will, as far as the data processing and everything, I mean, I think that's straightforward, and I could definitely help you out if you possibly need help. But so we start off. Project finding donors. Getting started. Okay, so this is the walkthrough. Uh, we will use several supervised algorithms to predict whether an individual's income is more than $50,000. A university or somewhere that's trying to get money, I think it was Charity ML, realizes that their donors who make more than $50,000 should be targeted because they're the ones more likely to invest or to give to their charity. So they decided to take data from the census, and based on whether an individual makes more than $50,000 or not, um, if they can discern whether an individual makes more than $50 based on the data from the census, that means the different features, the age, work environment, things to that nature, household, whatever features that are provided. So that is the problem we are working on right now, exploring the data. Okay, run the code below. I believe we actually did this code the last time that I was going over everything in the project. I could run it again. And notice this is just the header for the data. So we have the age, which looks to be a numerical, work class, category, education level. So we have different things. We have integers, floats, categories in this data set. And over here we have income. And you can see less than or equal to 50K is what it will be displayed for income. And let's actually put n equals 5 and run that. Okay. Let's try 10 and run that. Okay, good. So I just wanted to see examples of where it is less than or equal to 50K and when it is greater than 50K. So that's what it will look like in the income variable when it is less than or equal to 50K and greater than 50K. Now this is the exploration of data. What we're looking for is the total number of records in records, the number greater than $50,000, and the number less than or at most $50,000. So we also want the percentage of the individuals making more than 50,000 annually. So the total number of records, that's just the number of rows that are in this current data frame we have. So, how do we find the number of rows in the data frame we have? Well, what we can do is we can Google the number of rows in the data frame. the first thing in Stack Overflow, when you Google rows and data frame pandas, we can click on that. It is taking a little while. So while it's waiting, let's also do other problems or other things. So we have number of records where individual's income is more than $50,000. So we are looking for N greater than 50K. So we need a similar to a where condition at pandas. So where N is greater than 50K, right? So if we search where condition in pandas, Control C. Let that load, and that should have already popped up. Now, if we look right here, the guy is timing it. So we have time it for the shape, for the 0 count, and for the length. And as you can see, the length does better than all of it. What we have right here is microseconds plus nanoseconds and microseconds. And over here we have nanoseconds. So this definitely does a lot better, at least at least twice as better, at least twice as good, almost 50% the time of this time, I would say. So definitely statistically better. So what we're going to do is select the length of df.index, right? That is the quickest way to get the number of rows in the data frame. So where it says none, replace that with length of data frame.index. What is our data frame's name? Our data frame's name is data. So just replace data frame index with data. And there you have it. So now you want the number of records where individual's income is more than $50,000. So we want these right here, greater than 50K. So this is what it's going to look like, greater than 50K. If we look under where conditions in Panda that Google gave us, we can select rows from the data frame based on that value in column in Pandas, which is the first thing that you see when you just put in where condition. And that's going to load. And we have a whole bunch of great examples right here. So we have df and locate, where the column name is equal to some value. And that some value is going to be greater than 50K, what we already had, right? So that will give us the selection of rows. And from that selection of rows, we can then find the length, because we already know that the length dot index, because we already know that gives us the number of rows. So do is copy this and go back to your DS nanodegree and paste it here. So we locate that, and then we take the length of that, and then we put dot index. So it's finding length of this new data frame. Remember, our data is the data frame. We do not have a data set name df. So data.locate data column name. What is the column name? The column name is income. I like to copy and paste. It may take a little more time, but it makes sure that very little mistakes are made. So sum value. What is sum value? And sum value is greater than 50K. All right, and that should give us that. And number of records where individual's income is at most $50,000. So all that is the exact same thing, but at most $50,000. So Control C, Control V. And instead of these greater than 50K, we're going to choose the less than or equal to 50K. So Control C and Control V. So we have less than or equal to 50K right there. Percentage of individuals whose income is more than $50,000. So the percentage, that's just the number of greater divided by the total number of records, right? So Control C, Control V. Let's multiply it by 1.0 to make it sure it's a float, and divide it by the Control C, Control V, and let's multiply it by 1.0 to make sure that it's a float. It might not even be necessary, but let's like to make sure for this instance. So we could run this cell and see if everything looks all right. Looks good. So we have in total 45,000. And we see we have 45,000, 11,000 is making more than 50K. So it's definitely not 0.24%. As you can see, they wanted the percent. So we have to multiply this. Well, since we already have the 1 right here, multiply this by 100. Run that again. And now that makes more sense. 24% make more than $50,000 in this data set. All right. Now this is about feature exploration and making sure our data is ready to be inputted into the model. And this is just giving some things about the features, which ones are continuous, which ones are categorical. Transforming skewed continuous features. So they already, if you run this column right here, well, first, all this does is drop it. No, I guess it does not. So what this section of code does is it gets the thing that we're predicting and all of the predictors into different data frames. So now that we have the income raw and we have the features raw, without changing anything to the income and features. So now that is, we have 2 data frames with the predictor and with the features and the thing that we're predicting. So we visualize the skewed things in the data set, which is the capital gain and capital loss. As you can see, we have a very skewed activity. Capital gain, a lot is towards 0 and a little bit towards, looks like 100,000. And over here we have capital loss, which is quite similar as well. And normalizing this won't do too much good, because normalizing might give us a mean at approximately here. But as you can see, most things will not be normal. So will not be a normal distribution. So normalizing is not a good idea. Setting it into a scale from 0 to 1 right now isn't a good idea either, because setting it from a scale of 0 to 1 still would give us a rather awkward standard deviation and not necessarily understanding of things in the middle or between. So what we do is we log, we show the log of this data. So what we do is we take the log of the data, and the log of the data, the logarithm function, it rises exponentially, or takes things that are very, very high in value and places them a lot lower on scale, so that distributions to this nature will not look similar to this. So that's what we do in this line of code, is we take the log transformation of the capital gain and the capital loss, and from the log transformation, we make sure that we're not taking the logarithm of 0 by adding 1 to any value, which you don't have to add 1. You can add something even smaller than 1 to make sure you're not substituting much when you're taking the log. You can add 0.5, 0.01 in anything that you would prefer, but adding 1 still doesn't make too much of a difference. But in here, this code is already done for you, I believe. They add 1. So all you have to do is just run this. And now we can see it looks a lot better, right? You still have the ones that are close to 0, but for the most part, you have a smaller window and of discernibility, as opposed to what we had previously with without taking the logarithm, right? So going from 0 to 12 or 0 to 8 is a lot better than what this may look like right here. And here we have normalizing features. So for all the numerical variables, age, education, the 2 we just log transformed, and the hours per week, what we're going to do is we're going to normalize these features. That means from 0 to 1, make sure all the values are between 0 and 1. That means just subtract the minimum value and divide by the minimum minus divide by the range. So subtract the minimum value and divide by the range is how they get everything between 0 and 1. And that's what they do in this instance. Just get the features in between 0 and 1. We can run this. This code is already given to you. And now it just displays some of these features, all of them between 0 and 1, which is what we want. Now for the categorical variables, what we want to do is we want to one-hot encode the categorical variables. One-hot encoding should be familiar to you if it was in the neural networks, or the introduction neural networks lessons. If it was not new to you in the Introduction to Neural Networks lessons, one-hot encoding will be thoroughly explained to you in the upcoming lectures on neural networks. One-hot encoding, if you have a neural network, needs to predict different traffic signs, for example, whether it's a stop sign, a yield sign, or a speed limit sign. What one-hot encoding does is it sees which category it is and places a 1 in that category and a 0 in the others. So if you have 10 different categories, it will spit out a feature array that has 10 different columns of possibilities. So that is what one-hot encoding does. And that's what it's used for. So we want to one-hot encode all of the features using the get dummies from pandas. So to one-hot encode these, you should not want to one-hot encode all of the features from the log min-max transform. You only need to one-hot encode the features that are you only need to one-hot encode the features that are categorical. So we're not going to one-hot encode all the features in the log min-max transform data. We know the log min-max transform data is the data set we received after we applied the min-max scalar. So using this data set, we're going to use pandas.dummies to point one encoding all this data. So if we Google pandas.getDummies, oh, I didn't click on it. My bad. Excuse me. I just clicked on it. It is loading. All right. So a series or data frame is what it takes in. And a string, a list of strings, a dictionary of strings. You can use as prefixes. You have a separator for your prefix. The best thing I can do is look at the examples. So we have a PD series of data frame. We have a list A, B, C, and A that's a string. So a list that will then put each one of these characters by itself in a list. So we have 4 things in a list: A, B, C, and A. We use get dummies, and as you can tell, because we have 3 categories, A, B, and C, we have 3 different columns, and we see we have 0, 1, 1, 1. We have ones where A is present and 0 where it's not, and it's similar goes for B and C. And as you can see, there's another example with NaN, and when NaN is true, it has a column. And this is a great example. So we have a numerical column 1, 2, and 3. As you can tell, when you put in the get dummies in the whole data frame, we are outputted a only a numerical column. So the numerical column is not affected by the get dummies, which is the good thing. But another cool thing is that they have a prefix. So if you use a prefix COL, the prefix will then put COL and then A. So column 1, A, right? And A is, so column 1 is this column right here. So we have column 1A, column 1B, and for B we have A, B, and C. And so column B is column 2. So column 2 we have A, B, and C. They could have used different alphabets. They should have used different alphabets besides the same A, B, and C. But this is, as you can tell, this is still a good example because we have the prefix and we're using the prefix. So that's just an example of using the prefix as well. We may use the prefix in this example if needed to. I think it would probably be best if we did use the prefix so we know where the features came from, right? So we know it's like working class, state gov, or working class private, or things of that nature. It might be best if we use the prefix. So great example. What we're going to do is take that example, BD, get dummies, Control C. Control V. All right, so we have pandas, get dummies. You have the data frame, the prefix will be we might not want column 1 and column 2 as far as the names of the prefix. We most likely want all the names of the variables that are categorical. So we have work class, education level, marital status. So work class is the first one, Control C. Control V. And also we have education level. Marital status, occupation, I think the education level was underscored. And we have relationship, race, I think sex was the category after that. We have hours per week and native, well, actually, excuse me, we have only native country as the last one. Sure, actually. Yeah, that's the last one. Oh, whoops. I surely hope we saved all of that, or they're automatically saved. I was trying to scroll and see if the notebook is loading. The Google Hangouts takes a lot of space. Plus, I have other things. Oh, it's probably because I have other things running as well. Let me close this actually. See if that helps. May have helped. Okay. Hopefully everything looks like it did before. Looks like it. All right. Looks like we are still in business. Okay. Our last category. After race and sex was native country. All right. And the name of it is not data frame. The name of it is features log min-max transform. And so that's going to be called features final, right? So that has a name. Make sure education level is education level is underscore. Yeah. Okay. So, yeah, that is the same. And encode the income raw data to numerical values. Now, because the income raw data is just two possible things, 50K and greater than 50K, what we can do is create an income value in our, we can create it as a new series, okay? Or we can use the raw income variable to create a new series that targets when it is less than or equal to 50K, put a 0, and greater than 50K, put a 1. So what we're going to do is that would be a where condition in pandas. So what we can do is, I want to just do it. I want to show you where condition in pandas on Google to make sure you can do it as well. You know exactly where to look in order to get more information. Sometimes you may need to do different things besides just the basic formats and more understand the documentation. So we have the where, we have the condition, other, in place, false. So this is good because this is whether perform operation in place on the data or not. Okay. And looking at the examples is better. So we have a series 0, 1, 2, 3, 4. We have where S is greater than 0. And since we have nothing for the other condition, it gives it an and. And where it's greater than 0, we have the values 1, 2, 3, and 4. And this is just something different using mask. And this is where it is greater than 1. We have something for other, which is place the value 10. And you see what we have is we have 10s, and then we have where it is not greater than 1, we have the values. This is very useful. We can use this. So what I'm going to do is where it is equal to 50K, put a 0, and where it's equal to greater than 50K, put a 1. So all I'll do is just satisfy that condition where Control C equal to Control V. All right. And we have Control C and Control V. So where S, we don't have a data frame there named S. What we have is we have income raw. Remember, we got that. We separated the raw from the raw income from the features. So we have where we have incomes raw, 350K, and where income raw. So we want it less than 50K. We want a 0. We want greater than 50K. We want a 1. And what we're doing is we're changing the income raw. All right. And we can print the number of features after one hot encoding. And that's already done for you, as long as you use the features final column. And I uncommented this line already, so you can see the encoded feature names. So as we made sure that the names match what we are doing as far as work, class, education level, whatnot. So let's run this. Why isn't the I have to scroll up to run, do I? That's weird. For some reason, it's not allowing me to run anything. But the good news is, well, not really good news, but we still have 5 minutes because I forgot to put the link online before I started, which is why I put the link online. And here, I wasted 5 minutes or so, so I will keep going for a little more than another 5 minutes. So for some reason, we're not able to run this workspace. That is fine. This should be fine. Just to make sure this is fine, what I can also do is, and we can have income equals income dot where income is greater than 50K, put a 1. So what we're doing now is, instead of just doing it all in one step, we're doing this in one step, getting the income variable. We call it even income 0. And then from the income 0 variable, we're changing the other step and getting the income. And that should do the same thing, but you stay small precaution to make sure nothing is going wrong. So that should be fine. And this train, test, split, shuffles, get a training and a testing set. You should have seen that plenty of times already in your models. And going over the scores a little bit. So what we're going to be relying on is an accuracy F beta score as well. So as you already saw, what we have is we have 24% of the data that is classified as 24% of the data is classified as greater than $50,000. So, for example, if all of the data points were 0, which means that we relied on everything being less than or equal to 50K as far as income, we would already have an accuracy more than 75%. This is why using many different scores are good as a baseline. So, I mean, that 75% accuracy is a great way to discern whether your model is predicting or not very well. And because accuracy is always not the best thing to use, we use the F beta score, which takes a weighted average of the precision and recall based on which one we find is most important in this case. And remember, precision is the true positives divided by true positives plus false positives, which, in our expanded example, were the spam to all of the spam. So all of the classified as spam. So we have the spam that is classified as spam to everything that is classified as spam. And our recall is the spam that is classified as spam to all of the spam. Now, why in this case are we using a beta of 0.5, which means more emphasis is placed on precision? That is because, for example, if we had all of the data points and it said 0 were less than or equal to 50K and 1 was everywhere, which means that everything is classified as greater than or equal to 50K, then what we have is we have actually a 1 for recall, but our precision, which means that we have the number of false positives, that would be very low because that would be the entire data set, which would be our accuracy score subtracted from 1, which would be like 24%, which we have as our proportion that are actually 1, but our recall will be actually 1. So this is why we weight precision a little higher than the recall in this example. And so they want you to calculate the accuracy and they want you to calculate the accuracy, recall, and precision when everything is predicted as 1, which means that we predict all the incomes that individuals make more than 50K. They want you to calculate that. And so what you just, I believe I added this, just add import sklearn.metrics. And if you look at sklearn.metrics, you would already see we have accuracy score. So we are importing sklearn.metrics as SKM. So just use skmetrics dot accuracy score, and all the metrics are the same way. You have the true and then you have the predicted. So you have the true, which is the true is just the income column. So income column, and you have the predicted, which is the just ones, just a column of ones. Let's see if the place column of ones. Yeah, we place a column of ones. So we have NP dot, I believe it's ones like. Income dot, I believe that 2 NP array will work. So what we want is we want something that gives us ones for everything that is an income. So for however many variables, values that are in income, we want an array of ones that are like that. Instead, we can always just put array of ones, Python. Somebody has already Googled this, and you see NP1, thought it was ones like. Zeros like is something that you see in NumPy, and I thought it was ones like, but it is just ones. So we have the shape and desired data type for the array. In 8, default is the float 64, which is fine in this case. Okay. Actually, so we do have ones like, and ones like would probably return something, well, any type of input. So ones like does do that as well. So we have ones, 5, we have an array of that. So how about we use ones, because we have the documentation there. And instead of just income to NP dot array, since we all just need to know that, we can do income dot index. Remember, before we just take the length, the income dot index, and we get that. And we do something similar for the recall and precision, probably almost the same thing, right? It's just look at sklearn metrics. Just look at sklearn metrics, and you will see the calls for the precision, the recall, and the F-score. So you click on sklearn metrics. Under classification metrics, we have accuracy score, we have precision score, recall score, and we have the F beta score, which is what you'll be needing to use. F1 score will be with 1 as the value of the beta. When 1 is the value of the beta, the precision and recall are weighted equally. So we will like the F beta score, where we can choose the weight, and the weight will be 0.5 in this case, as it is already stated in the guidelines. So that is all I'm going to cover for today. That's all the time we have. Hope everybody was able to work along with me or use what I did to help them through. That is most of the project is actually just that, which is just looking at what they will like. They pretty much tell you to do statements and just do it. Okay, if you have any more questions, let me know. If you think it's best if I keep going over the project in the next webinar, let me know. I want to get Project One out the way. So yeah, I encourage you to get Project One done. And also, if you have any questions right now, please ask questions on the Slack channel right now if you are watching this webinar. I will give you a little minute, or do it on this Google Hangouts. I do have group chat open, so I should be able to see it. If I don't see it, then I'll use Slack. I'll give you till 8:05, which is about 3 more minutes. That's the 8:05 when 7:05 when I started, 8:05 when I stopped. Two more minutes. 1 more minute. No questions. I hope everybody is watching these webinars, or it's not, or I hope everybody's watching these webinars. I hope the 10 people who have not completed their project yet have watched this webinar, and if not watched the webinar, I'll send you an email and tell you that I did the walkthrough, and hopefully you respond whether you want me to continue in the next one or not. And as far as the 4 who have submitted their project, thank you. You were doing a great job. There are no questions, so I will end it at that. Thanks for watching, and peace out.